Hey everyone, welcome back. Today is an Edpuzzle recap video on samples and surveys. So what we aim to do here, which you probably already accomplished, but we just want to be extra sure, is make sure that we can identify the difference between a sample and a population, make sure that we can determine if a sampling is biased or not, and determine successfully what makes a sampling random. So let's hop right into it. When we last were together, which was Friday, we did a Desmos activity on samples and surveys, and it was really cool, super interesting. When I took it myself, I really enjoyed the activity. And now we are going to recap and make sure that we hit all of that success criteria, that we're going to make sure we hit our learning objectives. So we started off by looking at samples and surveys. So you guys made an assumption about what you think a sample and survey was based on this image. And I'm here to tell you that a sample is a selection of individuals from a population. So on the left of the screen, you should be able to notice that on the left, we have a population of a bunch of different people, depending on what the population is, right? We've got this population on the left, and we wanted to find out some information. So we sent out a survey and got a few people to answer it from the population. So the people that answered our survey or that we gathered data from, those are people in our sample, and they are a subset, they're a selection of people from our population. And the purpose for this is it's literally impossible to measure every single person in the population, even if the population is small, making sure we get those data results. So what we do is we usually just take a sample, a small selection of individuals from that, and then what we do with the results is we make a statistical inference about the populations, or we make an assumption, or we make a generalization about that particular population. So it's really important that we consider what our sample is when we are determining these things, as we are taking and collecting our data as we go to interpret the information. So no matter how your data is sampled, we have to think about how it's coming to us, because it can be skewed. It can have bias in it. It can change how we think about statistical problems. So think back to the airplane example from Desmos, and I'm actually going to just go and show you guys that slide from the Desmos activity. We can see that this was the activity, right? Abraham Wald and the bullet holes. During World War II, a statistician by the name of Abraham Wald was asked to help the British Air Force decide where to put extra armor on the planes. They gave him all of these charts of the bullet holes in the planes that were wounded in fighting, but they made it back safely to England. And it was up to us to guess what part of the plane would you put extra armor on? Would you put it here on the body? Would you put it by the tail end? Would you put it on the wings? And it was really important that we understood how this data was collected, because the answer to that problem was none of those positions. The answer to that was actually the nose, because that sample from the population was only the sample of planes that successfully made it back. But we're interested in the sample of planes that did not make it back successfully, and those were ones that had damage to the engine, right? So that's why the nose of the plane made the most sense for that. So we have to really think about how we select a sample. And how we select a sample has a lot to do with whether or not our sample is going to have bias or not. And when we asked you guys in the Desmos activity, like, hey, like, have you ever heard of bias? What does it mean to you? Every single person has said they've heard that before and said it's an opinion that you have. It's something that could be positive or negative. It's something that can definitely affect your decision making in the future. It's something that can affect the way that you think about things, right? So for statistics, specifically speaking, a bias is a study flaw, and that study flaw leads to unrepresentative or inaccurate estimates of the population. right? So take a look at the image on the right here. We have this population of dots. What that represents doesn't really matter, right? But we have red dots and green dots. And if we were to select a sample, like the sample on the right, this sample has inherited bias because from the entire population on the left, in our sample, we have selected all of the green dots, every single one, and then 3 more red ones, and are saying that this sample, we're going to make decisions and say this sample affects and represents the viewpoints of that population. Clearly here we can see that the sample is the minority of the population. We would never go out and take information from the minority and say that that is the viewpoints of the entire populations. We would never go out and survey, let's say we go out to all college campuses, we take a survey of colleges, and the minority is like maybe people that are attending a community college, which we love a community college, right? But it is a little bit of a different experience. And say our sample ended up having a majority of community college students' results, right? A couple 4 years, a couple UCs, a couple privates, but a majority of them in our sample was results from community college. And then we took these statistics and presented them as the viewpoints of all college-going students. That would be unrepresentative of all college students, and it would be inaccurate because we're not including as much of the entire population. So when we are thinking about sampling bias, we have to consider what the population is. In that previous example I just made up off the top of my head, the population is students attending college, right? And the sample should be an accurate representation of that population. Otherwise, it might have bias, such as only representing a majority of the sample being community college students versus Cal States versus 4 years versus the Ivy Leagues, the private colleges, international. I mean, even more so on a more broad scale, we could talk about trade schools and things like that, right? They're still school, but we need to identify the population in the sample to identify if there might be any bias. And then once we have identified those two things, we need to explain how the sampled individuals, how the results from the sample might be different from the general population. If we can do that, then we can successfully identify bias. So there are 4 main sampling types that we're going to talk about. There are more, but for our class, there was 4. There's a convenient sample, which basically selects any members who are conveniently and readily available. There is a self-selected sample, meaning we're just having people self-select themselves. They're volunteers to take our survey, to kind of volunteer themselves to allow their results to be a part of our data. There is systematic sample, which is very systematic, right? You order the population and then select it at regular intervals. And there's a random sample. All members of the population are equally likely to be chosen. So I'm going to give us another example of how we might sample things and go through the sampling types of that particular example. So let's say that I wanted to survey Algebra 2 students, okay? That's my population, Algebra 2 students. A convenient sample that I could take would be that I could ask a question to my Algebra 2 students that are entering my classroom. I could ask them a question and collect the data, and that would be a convenience sample, right? Because the students are coming here. It's convenient for them. It's convenient for me. They're readily available. And then they'll answer my question and I'll collect the data on it. I could even stand at the front gates of TVHS and ask people questions. And that would be an example of a convenient sample. A self-selected example, or a self-selected sample example would be, for example, me posting a survey on Canvas, right? And saying like, hey, if you have a minute, would you mind taking the survey for me? And the people who volunteer to take the survey for me are self-selected. They're volunteering, they're going in on their own time, and they're taking the survey on my behalf for me. So that would be an example of self-selected. a systematic sample could be that I am taking the students in my class, looking at my class roster in ABC order, and I'm ordering the population from ABC order, right? That's how I'm ordering it. Okay, and I select every 5th student. I send you an email and I send you the link to take my survey. And I said, hey, would you please take this survey, right? I ordered my Algebra 2 students. I ordered the population. And then I selected it at regular intervals and send it out and hope to collect data in that way. And lastly, a random sample would be all members of the population are equally likely to be chosen. Okay, so a way that I could make a random sample would be that, say I take all students, all Algebra 2 students in TVHS, right? I go and find all of them. I put them in a spreadsheet and I order their names from ABC order, or really it doesn't matter. Just put them all in a spreadsheet, right? And then I use a random number generator to select numbers of lines, and those random number generators associates with the student, and then I email them my survey. I'm not restricting it to just my class. Every single person is put into the pool and they're equally as likely to be chosen at random. And that is an example of a random sample. Notice that all the examples I previously talked about had some bias. I was specifically talking about only Algebra 2 students in my class, but I'm not the only Algebra 2 teacher here. So that's a way that we can interpret and think about the population at large and see if there is any bias. As a matter of fact, I could do a random random name generator of students just in my class, and that will still have a little bit of bias if I'm going to present my findings as data that represents all Algebra 2 students at Temecula Valley. However, if I presented it as data of all Algebra 2 students that are my students, then it has a little less bias. Depends on how you spin the data. So a few more examples of a convenient sample could just be a reporter is interviewing people that are coming and going from a public park, right? It's very convenient for the reporter. It's very convenient for the park goers. A self-selected sample, and this came straight from Desmos, was a newspaper article asking readers to express their opinions. A lot of times newspaper articles will do that, or even like news outlets. They'll ask their readers, the people that subscribe to them, to give their opinions, and then they'll collect that data and present it as Americans at large, or because the people happen to be American. Or maybe they'll be a little bit more specific and disclose that the population is just people who read their newspaper or subscribe to their channels, right? A systematic sample could be ASB conducting a survey out here for us and asking every 5th person on the 9th grade roster. That would be a systematic sample. And a random sample, what would be that all of the employees' information, all of their income specifically. Everyone has the income, and then it's put in on a little piece of paper and put into a jar, and then they shake it up, and then we randomly pull little pieces of paper out of there. That would be a random sample of income of employees. So, which of the following samples does not contain bias? Would it be convenience, self-selected, systematic, or random? Hopefully you chose random, right? Random is the best way to sample and not contain any bias, right? If you assign every student in the school a number and use a random number generator to choose 100 students, everyone's equally likely. There's no way to have any inherent bias in that type of sampling. And ultimately, that's the kind of sampling we're looking for as we collect data. Or if we want to think about how that data is being accurately represented. So convenient sample, self-selected sample, systemic sample, no way. Drake says no, but random sampling? Absolutely. So in order to avoid bias, we gotta randomly sample. A random sampling is a sampling method in which every possible group of individuals in the population has an equal chance of being selected. So when a population has a reduced chance of being included, it's not going to be representative, which is why the best survey type to get accurate information about the entire population is a random sample. We don't want to exclude or over include opinions or values or ideas of something that is not typically representative of the entire population at large. So, what did you learn? Here's a learning objective check. Learning objective check. What is the difference between a sample and a population? Question number 2, how might you determine if a sample is biased? And lastly, what makes a sampling random? Tell me your thoughts. Awesome. So the difference between a sample and a population is a sample is a small part of a population. The entire population cannot possibly be surveyed, so we must choose a sample that is representative of the population. How might you determine if a sample is biased? A sample will contain bias if it's not random. We must ask ourselves how the sampled individuals might differ from the general population, and then assess whether or not there is implicit or explicit bias that is put forth by that sampling. And lastly, what makes the sampling random? A random sample is conducted in a way so that all members are equally likely to be chosen for our survey. So that's all I have for you today. Thank you so much for learning with me and checking it out. I hope you guys really liked that activity, and I hope you liked the summary. Have a great rest of your day, guys. Bye. Oh, I forgot. You're going to have an assessment. Okay. Hope you watched this Edpuzzle before, because sampling is one question on there. So remember, you can use your notes. You can use a calculator, but you absolutely cannot use any outside resources other than your own noggin. Okay. Good luck. I'm sure you guys are going to do absolutely fantastic. Have a great rest of your day, and I will see you next week. No, this week. Later. I will see you Tuesday. Or wait, no, actually, I see you guys Wednesday. Sorry, I'm all backwards. I'll see you guys in the next class. Bye.